Application Programming Interface, or API, exposes the data and functions of a software application to third-party users. In digital business, the API economy is one of the key determinants of value for provided services. With the rise in the number of publicly available APIs, understanding each API endpoint manually is not only labor-intensive, but also an error-prone task for software developers. In addition, APIs may be revised or updated regularly, and keeping track of these changes can create significant overheads. Finally, due to the complexity of understanding the sheer number of APIs, it is difficult for software developers to find possible API combinations, for instance, API mashups. In this video, we demonstrate the API Learning Platform, which employs machine learning technologies that help software engineers efficiently search APIs, validate APIs, and generate API mashups. These can automatically generate a machine-readable format of API functionalities from its documentation, understand API descriptions, validate extracted information through automatic API validation, and finally recommend API mashups for specific purposes. As of now, the API Learning Platform has collected over 14,000 APIs, learning various structures of API documentation. We focused on the REST category of APIs to generate a set of machine-readable API specifications with an accuracy of 84%. This video of our prototype enables users to quickly find relevant APIs, automatically verify API availability, and get a set of API mashup recommendations. Our platform collects a large number of API documentations and processes the whole API corpus to extract information. This demonstration shows the results of such information extraction. Let's get started. Our demo is presented as a web-based GUI that enables the user to search any API based on category, title, or a specific keyword. Let me first show the list of all available machine-readable REST APIs. By typing *, it retrieves the list of all REST APIs based on the OpenAPI specification format. Now, let's focus on one specific API, for example, the LinkedIn API. First, I will search the keyword. Notice that the search box shows me a list of suggested keywords that comes from API titles or categories. By typing LinkedIn, it returns all related LinkedIn APIs, including those that have LinkedIn as a keyword. Let's select one of them. It returns metadata of an API on the first screen. We may choose different view. In this list, there are 3 different views. The first shows metadata of an API. The second view shows the list of extracted endpoints from the API documentations. The third view shows the API mashup recommendation for the selected API, and the last view shows all information in one page. For example, it shows title, description, security protocols, Swagger format or OpenAPI specification version, and SSL support for the LinkedIn API. Now let's select the second view, the list of API endpoints. Let's validate the first endpoint. As we can see, it calls and validates the endpoint in real time and returns its error or a checkmark. This API endpoint is invalid. Let's try another. As we can see, this endpoint is valid. Also, the next one is a valid endpoint. There is a link labeled source. Clicking on it retrieves the original API documentation source file. The web crawler stores a copy of the source in our repository. Let's select the API mashup view. It returns possible API mashups for the LinkedIn API. For example, the first row shows LinkedIn API can be combined with Google Plus API with a similarity score of 84%. That shows how similar between the input and output parameter descriptions between the two APIs. In general, a higher similarity score means more likely that the two APIs can be combined. It also shows another API mashup recommendation for Tumblr API with an 81% similarity score. We also collect information from crowdsourcing, websites including Programmable Web, API Harmony, IFTTT, and GitHub to see if someone added a record of an API mashup according to human knowledge, or used the API mashup in a real IFTTT or GitHub project. For instance, we found an API mashup recommendation programmable website that recommends an API mashup of LinkedIn API with Google Plus API. Yes refers to finding a record, and no refers to no record found in the given source. If we click on the Graph button, it returns a visual view of API mashup recommendations. The x-axis represents the API recommendation, and the y-axis represents the similarity score of an API recommendation. On the top of each bar shows the source of the confirmation. If we select All view, it returns all information of the API metadata, endpoints, validation, and API mashup service recommendations. We may also validate each endpoint in this view. The source of all views is a JSON file, and the GUI automatically generates a HTML page for each selected view of a JSON source file because all JSON source file compliance with Open API specifications. We may view the JSON source file by clicking on a View JSON link button. It returns all API specifications in a JSON tree structure view that includes all information. It is written based on Open API Specification, OAS. If we click on Raw Data, we can see the raw data of the JSON file. If we go back to the home page, there is a link to the API Learning User Guide that helps interacting with this platform. This document describes all components including API corpus, API validation, and API mashup service recommendations. Let me search for another API. For example, Google Identity Toolkit. Let's select one of them from our repository. I will choose Different View. I can validate an endpoint. I can check original API documentation. I can review API mashup recommendations. I can open Graph View of API mashup service recommendations. It also retrieves OAS-based JSON file.